So today's topics, really, we're just going to run through a few things. And the first one's actually most important of all in terms of what this isn't. This absolutely isn't a few things which we'll touch on. We'll talk about what the point of it all, what serverless is and what it means, and then how we can use that, hopefully, with the tools that we've already got. So, to start off, what this isn't. And it's actually quite important to frame the whole discussion about serverless and about this topic in terms of what this absolutely isn't. So, what we're talking about here is not a cure-all solution for all of your hosting problems. This isn't just something you can drop in to your existing structure and it'll all be wonderful and it's the miracle cure that all the marketing people would love us to believe. This most definitely is not a beautifully engineered solution. What we've got here is really an experiment, if you like. I want you to look at what we could do, and you'll see, hopefully, what could be possible from there. But as I say, this is not a beautifully engineered solution. This is most definitely not something that you should go and check out all these modules and put them onto your production site. It's going to end badly if you do that. As I say, it's not a replacement for your existing hosting systems, and specifically today, this is not going to be a live demo of anything, because, well, you know. So, what's the point? What actually started all this off? Well, it was started by really one of our clients. We've got a client who runs a site there based in Japan. And we built a site for them. The purpose of the site was to try and generate tourism interest, particularly in the initial stages in Europe. So we built the site, we hosted it in the UK, all was good, all was fine. Once we'd done that, they said, well, we need to expand the reach. We want to make it bigger. We want to get customers from the US. Oh, okay, that's fine. We kind of stuck with the European solution for now because, again, budgetary constraints, there's all kinds of problems that we could have gone into. And from the testing we did, it was acceptable. It wasn't perfect by any stretch of the imagination, but load times, that kind of thing, were okay. The real problem came when a bureaucrat in the local authority in Japan said, this site's really slow, it's terrible. And of course, from Japan, it was absolutely terrible. And also from locations in all through Asia, in Australia, New Zealand, it's painfully slow, as you'd expect. So we had a conversation with them and really said to them, well, you know, we can do it. We can fix this for you, and we think it's going to cost you this much money to fix. And they just don't have the money. They're a local authority. They're a small council. They've got lots of budgetary constraints. And that was really the opportunity for us to say, well, let's try and solve the problem another way. Let's look at this from a completely different perspective. And that's kind of what we did. And this was the perspective we looked at it from. We wanted to try and make a quicker, more resilient, scalable, if possible, hosting environment. We wanted to create a proof of concept because our thinking was that if we can make this work now, it may be something we can use going forward, and there may be opportunities for us to use that in different environments and for different applications. And that really, again, follows on from what Stefan was talking about yesterday, was to start thinking about the delivery of the website in a different way that we always had done, and we have done for absolutely years. The critical things, these down here, we wanted to do as little work as possible to make this happen. We had an existing website. They'd invested in that site, and there was no way we were going to be able to sell to them a complete re-engineering of that site. So this was the challenge. Can we do this without doing a whole bunch of work? Can we do this without just spending a whole bunch of money on new hosting infrastructure, on distributing the website geographically across systems? You know, could it be done? This was a challenge, and this was an experiment, really. And that's kind of what you're going to see today, is the result of that experiment. And the last one on there actually was the one that's most interesting. We wanted to try and make something that we could retrofit to an existing SilverStripe website without a lot of technical overhead, without a lot of cost, so that it was something we could offer to other clients who wanted better performance, who wanted specific features, and hopefully we are going to be able to achieve that. So this is very much step 0 of a process, as I say. Don't expect this to just go out and work, but this is where it brought us. Now, obviously, you have all heard, without question, the serverless word. It's everywhere at the moment. And if you believe everybody, then it's going to solve all of your hosting problems for the rest of your life. I hate the term, I have to say. It's not a term I like. It's kind of meaningless, and it doesn't really tell you anything about what it does. But in general terms, now we will cover a lot of stuff you already know, I realize this, but there are 2 reasons I'm going to do that. 1, you're probably partly hungover. 2, it does give us a bit of context for what we're talking about. And actually, there's a 3rd reason, is it helps me pad out the talk quite a lot, so I sound a bit more interesting. Okay, so serverless, what does it mean? It's mostly a marketing term, and as you will have heard, it's a model based primarily on the execution of functions. So you break down your application into a specific set of functions, and each one of those functions runs, and as Stefan described yesterday, it runs and then it's disposed of. Generally, pricing cost is done on a resource consumption basis, so how long these things take to run, how many cycles they take, rather than with a lot of the more virtual cloud-based systems where you're paying for a pre-provisioned capacity or a certain amount of available processing power, whatever it may be. So what you tend to have are very short, quick functions that run to do the tasks you want. There are a few providers for this. I'm going to talk about a couple today. One is obviously AWS, which we've talked about a little bit, and the other is Cloudflare. And Cloudflare are doing, probably they're one of the people who are trying to push this forward quite hard at the moment, certainly in the areas that I've been looking at. So there are a few differences. Lambda's Edge offering, you can run on that all kinds of stuff. You can run Java and Go, PowerShell, Node, C#, Python. There's kind of all kinds of stuff you can run on there. Cloudflare services will actually run on Google's V8 engine. So that's the open source JavaScript, WebAssembly execution environment that obviously it's a bit more limited, but by limiting their language choice, I think they have focused as much as possible on getting the performance there, because that's the one thing that they really are pushing, is how quickly their edge applications will run. Okay, so to start off with, again, just for a bit of context, we'll have a very brief look at stuff we all know, okay? So familiar models, we've got very standard, single kind of server, single place. There's the internet, there's the user. We all know the pitfalls of this. It doesn't scale. It's very vulnerable to network congestion, to attacks. There's all kinds of single points of failure in here. But for a lot of sites, that's kind of what we run. Small websites, we run on this kind of system whereby we've got all these baked-in problems that we can't do much with. Now, you can add some redundancy. So you can add load balancers, you can put clusters of web servers in there, you can have back-end database servers, you can consume database services, so you don't have to worry about that infrastructure. But again, same set of problems in terms of there are still in certain cases, there are single points of failure. It still can be susceptible to attacks and failures, and it still can suffer, certainly in this instance, it can suffer from geographical issues, which is one of the things we had to solve, is that if this lot is in London, then that doesn't help somebody who's in Japan. So Your next step, this is the kind of stuff we were talking about yesterday. Sorry about the high quality graphic. But this, you go big, you deploy globally. You have multiple zones in multiple regions. You have elastic load balancers split across the world. This solves most of the problems, make no mistake. This is how a lot of systems work and work very well. So these are services such as Google Compute, AWS. They've all got these applications as services, so you've got databases, you've got redundancy. The problems with this are that it's just a bigger version of what we're already doing. It's a very clever version of what we're doing, but it's just a bigger version of what we're doing. And also, the biggest problem in a lot of cases is that it is eye-wateringly expensive. If you start to run a large system like this, you can be into thousands of dollars a month very, very quickly for a widely distributed site. We're going to take a brief detour because, again, some of this you'll know, but some of this, if you don't know, is important because we're just going to talk a little bit about DNS. DNS is critical and is key to the next steps of this. So we're probably all familiar with the unicast DNS model. So you've got a host there, server of some kind, whatever it may be, and that's got an IP address. And in the unicast model, pretty much you've got one IP address, one host, one location. So that's the way it works. Now, in terms of resilience, that's a terrible model. Anything can happen in this network here, and your server becomes unavailable. So the reason that Anycast exists, and you'll find that every CDN provider, all of the cloud providers we talked about earlier on, they will all use an Anycast model. And in fairly simplistic terms, the Anycast model allows multiple hosts to share the same IP address. So when this person here says, I want to access this IP address for whatever reason, be it for a DNS query or whatever, then the root, it knows the IP address, and the network says, well, the quickest way for you to get to that IP address is to look at it on that host. Whereas if I'm a person over here, the quickest way for me to get to that IP address will be on that host. So you get this baked-in redundancy, intelligence of routing, which means that if these are distributed around the world, then you always have got availability. And when one of these dies, if this gets attacked, if the server blows up, if the power goes off, if there's a hurricane that knocks down the data center, whatever it may be, the system stays up. So that's how you'll find Encapsula and Cloudflare and AWS. They all manage their systems. And a lot of the underlying internet structure also runs on an Anycast basis. So, enough of this nonsense. What's this got to do with serverless? This is a network map from Cloudflare. And Cloudflare are the people that I've been really testing with. So each one of these locations is a data center. There's, I think, 194 at the moment, 90 different countries around the world. So in each one of these data centers, the colors on the dots don't mean anything, by the way. Each one of these data centers, there are obviously thousands of machines. And in all of those data centers, there are DNS servers, there are application servers, there's all kinds of stuff. There's firewalls and routing. There's everything goes on in all of these data centers. Obviously, AWS has a similar network. Encapsula has a similar network. All of the guys have networks of this type. And they have very high-speed links, private links between their data centers as well, just to help move that traffic globally around their own networks. So when we talk about distributed networks and you think about the Anycast system, if every single one of these is operating as a DNS server on that IP address, and every single one of these is routing traffic according to the performance that's available to it, according to the local network conditions, according to the health of its hosts, then you can see you've got a very resilient network that can move traffic around in an efficient way. How can we use it, is the obvious question. So if you think about what we've just seen, with a fairly simple model, if we put our code in all of those data centers, and that's the code that's actually delivering content to our clients, you get naturally a very quick response to those queries. We don't need to rely on a single machine, we don't need to rely on any clusters, and we definitely don't need to spend thousands of pounds on a full cloud-based architecture. So we get something that can withstand big traffic spikes, that can withstand attacks, and can withstand failures in the network. And more importantly, and again, in the context of this, it's quick everywhere in the world. You get that by default because you get your content out to the edge networks straight away. Okay, so we're going to take a few steps to get to our serverless system. And this is, as I say, this is based on taking an existing site. If you were starting a site from scratch, you probably wouldn't do this. This is taking something you've already got, taking knowledge you've already got, familiarity with systems you've already got, and trying to actually get some benefit from the new technology that's about. So, step one. Obviously, if you've got a single host and it's got a bunch of assets on it, dragging those assets all the way around the world every time somebody wants to see them is just poor for experience and performance all over the place. So the first step we took in this case was to use the SilverStripe S3 module. We talked about it yesterday. And with CMS4, obviously the assets via Fly system, as Werner helped us yesterday, the assets can be moved automatically onto S3. Now, I chose S3 because there was a module available for no other reason than that. I don't have any particular affiliation for it. But what I wanted to do was get the assets off the server. That was the important thing. There are other services available. I think Rackspace do one. There's got Cloudinary that we talked about yesterday. You know, there's all kinds of things that you could do. I chose S3. Very straightforward. Install the module, upload all of the existing files into the S3 bucket, and away we go. So straight away, we have a single common store for the site content, and it's kind of seamless. The client doesn't know anything about it. We don't need to do anything about it. It just works. So what that does, it also adds, rewrites all of the URLs for assets in your site. It rewrites them and points them all at the S3 server. Okay. S3 is great, but again, still geographically limited. So if I pick my S3 bucket in London, then that's where it sits. So same problem in terms of, I mean, okay, their networks are faster, but the same problem is you've still got to drag these assets all around the world. So the next thing we did was to add a CDN layer on top of that. And again, there's lots of ways you can do it. These are the choices we made in this experiment. They're not necessarily the right choices, but they're the choices we made. So in this case, we did a CloudFront distribution. CloudFront obviously just takes assets from the S3 bucket, serves them through AWS's CDN. And obviously that's going to reduce the latency because it's putting a high-speed network path specifically to your assets, and it's keeping cached copies of those assets at the edge. So those are the reasons for doing this. We have got a very, very basic module which we wrote. It's just a very simple middleware that rewrites the assets from S3. So if you get this hugely complicated URL here, it'll just rewrite it, stick your CloudFront distribution there. It is the simplest piece of code. So all that does, then, the step we've got to is we've got a site still running on our origin server, but all of our assets are stored in S3, and they're being delivered to the client via CloudFront. That in itself is actually a big help. That does a lot for the speed of the site, because whilst the initial page is still being loaded directly from the origin, all of the assets are being sent out via CDN. So there's less load on the server, there's less load in the network, and your browser is making concurrent requests to different places. Site resources are the other thing. So site resources, CSS, JavaScript files, things like that. Currently, again, the the model is we've got an existing site which uses existing technologies. We could rewrite this, we could make it all very clever, so all that stuff is being deployed directly to S3 or directly to somewhere else, but that's not what this is about. This is about, as I say, doing as little work as possible. So, in this case, all we did here, we've got, again, just another simple middleware that rewrites anything in resources, and you can specify exactly what you want it to be. So if you've got other files, if you've got themes, you've got things like that, it's a very simple configuration process that just lets you set this to a different URL. And it does it transparently. It does it on top of anything else you've got on the site. The point here is that we don't have to worry about what other modules we've got, what other code we've got working. This gets it at the end of the process and just changes what it needs to change. Now, in this particular case, what we did here is we just stuck Cloudflare in front of those assets. So, because these aren't the sort of the bulk of the user-uploaded assets, these are the site-generated assets. It means they are going to be used on every request, and there's not a lot of size there. And the reason that's important is that this is effectively a caching model. So what this does is it'll fetch the file, first time, it'll fetch the file from the origin server, and it'll hold a copy at the edge, whichever node it's at, it'll hold a copy there. The problem with that process, I mean, it's very good, but the problem with that process is more popular files take priority. It's a favoritism system. So if you've got a file that's being requested all the time, there's a good chance it's going to be in the cache. If you've got a file that's being requested infrequently, or you've got a site which isn't very busy, then there's a good chance that that's going to get expelled from the cache because it's not very popular and there's a limited amount of space in there. So for stuff like this, which is small, it's not going to affect us too much if we have to do an origin fetch every single time or infrequently. And as I say, these are used for every page on the website. So there's a much better chance that this will be valid and in the cache. With our assets, there's a good chance they will be expelled from the cache quite often, unless we've got pages which are really, really popular. So that's really the reason for the difference in approach between those two systems. Okay, static publisher, again, we talked about yesterday. And one of the things actually that Stefan said in his talk was quite interesting. He said there's no open source solution to doing static publishing for serverless. Well, I disagree, because I think actually SilverStripe CMS, if you can make it work and if you can deploy it in the right way, is absolutely what that can be. It's obviously an excellent CMS system. We all know how much the users like it. We know how easy it is to customize. The only bit missing from that equation is getting the output of it stuck onto the serverless network. And that was the missing piece. That was the bit that we needed to do. In case you haven't used Static Publisher, I'm sure you all have, all Static Publisher does is effectively makes a request to the page on the site locally and takes the output of that and stores it. And then you've got a static HTML page stored in a file on the server, which, with a bit of clever rewriting, whatever it may be, when a request comes in, it just deploys that page. You can bypass PHP, you're just dealing with what Apache is actually good at, which is serving pages quickly. So that's static publishing. Obviously, there are issues with static publishing in the fact it's static. So if you've got content which is dynamically generated, there may be news feeds, there may be shopping carts. There could be all kinds of reasons you've got dynamic content in the pages. At this point, all we do with that is we just take that bit of the page out and we just load it via Ajax. So once the page loads, the main HTML of the page loads, we just load it in via Ajax. I'm sure there are other ways to do that, which we'll hear about this afternoon from Stacy, who will probably give us much better ideas about how we can do that with some performance. But again, that's the whole point. It's just trying not to re-engineer everything. There are better ways if you're starting from scratch. Okay, so nearly there. We've now got a site that is generating static HTML. That gives us a very quick response time from the origin server. We've got all of the other resources being served from a CDN or multiple CDNs to make sure we've got quick response times on those, and we haven't got a massive load time on our server. And we've automatically got, as a result of this, predominantly a geographically redundant system. With the exception of our origin server, we've got a fully geographical redundant system that's going to be fairly performant. So what's left? Well, the edge is what's left, the serverless edge. So in all of those systems we looked at earlier on, and in the all those little dots, as I say, there are serverless computers, serverless servers. So what we want to do is we want to get our code into that serverless technology. And obviously that means that those serverless nodes are going to deal with the traffic we've got. And most of the traffic should never come anywhere near our origin server. The origin server is still there, it still works. That's what we run the CMS on. So we're not walking away from what we've already got. CMS is exactly the same. Everything stays the way it is. And as I said earlier, there are various systems. AWS has Lambda Edge. Cloudflare has a system which we're going to talk about, and that's what we've deployed on today. We've tested on both. Cloudflare we felt was slightly quicker. So, Cloudflare Workers, that's their name for the system that runs serverless technology. That's the name for the environment that you can execute your scripts in. As I say, runs V8 engine, you can use Rust, you can use TypeScript, you can use, it compiles down to WebAssembly, so there's plenty of scope there. This is the point to say I am not a front-end developer. I am by no means an expert on this thing I'm talking about. I'm just kind of bringing you along for the ride on my experiment here. Now, when you set these workers up, they can respond to specific URLs or specific URL patterns. So you can have multiple workers working within your domain or with your subdomain, whatever it may be, and each one of those can do a specific function. It's obviously, it's relatively low cost, depending on the amount of traffic you've got. We'll talk about the cost in a minute, but it's 50 cents, I think it is, for 1 million requests. So if your site's not doing 10 million requests a day, that's actually not a bad pricing model. And you can do all kinds of cool things with workers. They can have all kinds of conditional logic in them. Anything you can do in Node or those languages, you can do. You can pick up and modify request headers, response headers. You can do conditional routing. You can do authentication. There's kind of all kinds of things you can do within these within this environment. We're not going to do that because, as I say, this is not my area of expertise. So that's great. We've got worker scripts. They can do something or other, but it doesn't solve the problem. It doesn't actually solve the problem we're trying to do, which is to serve our web content directly from the edge. What Cloudflare released fairly recently is something called KV, and KV is key value. Key value storage, you're probably familiar with in terms of things like Redis, Memcache. It's here's a key, here's a bunch of data for it, store it somewhere. And the beauty of Workers KV is that the KV store sits at the edge in the same network as the workers. It is what they call eventually consistent. So if you send an update to KV, you send a new value and store it in KV, that distributes itself to all of the nodes in the Cloudflare network. They say within about 2 minutes, which is pretty good. Unless you're doing something very, very fast, that's a pretty good update time for what we're doing. And as I say, it's a simple key value storage system. The keys can be up to 512 bytes. You can store up to 2 meg of data in each, against each key. Now, to give you an idea, the site that we've been testing on, which is just a very small site, it uses a total of about 60K. So you've got about 60K of data stored, and it's only a 5-6 page website. But the point is, 2 meg per key is actually quite a lot of data. You don't really want a page which is 2 megabytes big. And you can also give them TTL values for automatic expiry. So these can also work like a cache. As well as working like a storage system, they can work like a cache. It's not dissimilar to how you may use DynamoDB, and DynamoDB on AWS is the other system we've tested this on. We've got a plugin that we built to actually do the same job with DynamoDB. But, as I say, our view was that this actually is quicker. Now, in the standard $5 a month bill, that includes 10 million read requests, 1 million write requests, and 1 million delete requests. So again, that just gives you an idea of the scale and where this might be appropriate for an application. You can run up to 50 milliseconds of time per request. And you get, in total, for that $5, you get a gigabyte of storage, of KV storage. So again, obviously you can go bigger than that, but in the $5 tier, that's kind of where you sit. That's what you get. So, important thing is, what are we actually going to do with it? Well, what we do with the static site we've got and getting it to the edge, that's the missing piece, as I say. So what we've got is a system which takes the output. It's a back-end system for Static Publisher. And it takes the output of Static Publisher and it pushes it into the KV store. Once we've done that, we have our edge worker. Now, apologies to any JavaScript developers in the room. This is our edge worker, okay? Very, very simple. And this runs the whole site. This runs the entire site. If we just go through it line by line, there's a request handler here, and all that does is it gets the request, cleans up the URL a little bit just to account for slashes and trailing slashes and things like that, and then it makes a request to the KV store. And it sends the URL path it gets, example.com/give me a page, and it goes off to KV store and says, okay, have you got the content for this page? If it has, all it does, I mean, we've got a bit of debugging in there with some headers and all kinds of stuff like that. But basically, what it does, if it's got that content, it just spits it straight back to the client. The origin server never sees it. It's just static HTML. Doesn't need to be clever. If it hasn't, then all it does is it just hops off back to the origin server and says, oh, I don't know what to do with this page. Can you give me the content? The origin server loads the page and sends it off, and it just returns it. It is the very, very simple process. And this covers most of the content on the website. So we've now got the mechanisms on the edge to deal with the requests. We know how to do this. And we need to push the page data. As I said just now, we push that page data from Static Publisher up to the KV store. And again, we've just got a little Edge Publisher engine which sits with Static Publisher. And what that does, it provides a back end for Static Publisher with Cloudflare KV or DynamoDB. And it takes the output. Whenever Static Publisher creates a page, it pushes that data straight up to the data store. The reason this is effective is because it deals with all of your existing processes. As I say, we're not changing anything on the origin website. You could switch this off. You can just take the whole lot out, turn off your worker, and your site will be back exactly the way it was before. Nothing has changed on the site. We've done a couple of extra things. We can deal with creation of namespaces in Cloudflare, things like that. And importantly, it sends data directly when the pages are published. This isn't a pull device from the edge. The edge doesn't say, oh, give me some data. We're saying, have these pages. Serve these pages from the edge if you can. And the advantage of doing that is one of the big strengths of Static Publisher, which is that you can tell it which pages not to publish. So if there are specific pages that you don't want to be dealt with by this system, you can just exclude them from the publishing. So this will only deal with things that you actually want out there, which, again, with a bit of thought and a bit of structure, it means that you can be serving all of the spiders and the bots and the people who are browsing your site for no real reason. You can just deal with them straight on the edge. But the people you need to deal with and people you need to interact with, you can still bring them back into your environment and and deal with them in that case. And one of the things you can do with workers is you can make conditional routing. So if there's a particular session cookie set, if there's a particular header set, you can say, well, actually, no, I'm not going to deal with this. I'm going to pass this off to the application. And obviously, because it's a caching system, we haven't got to worry about whether it's being expired, whether it's been expelled from the cache for some reason. It's under our control for the most part. Does it work? That's the question. Well, so far. It's an alternative. It's definitely an alternative approach to hosting. It's not, as I say, it's not a drop-in replacement. For the models we've looked at, the costs compared to a fully redundant, load-balanced, backed-up, resilient system using more traditional methods is very good. We'll see what happens when we actually start to test this on real sites. It's obviously massively scalable, it's highly resistant, and the point, as I say earlier, I made, it's more controllable than having to rely on somebody else's cache to decide whether they're going to deliver your content. You're paying to have your content out there on the edge. So, kind of real-world test. We set up a little basic website to start off with, just to actually develop this, to test the theories. And we are now in kind of the stages of testing. We're about to roll it out onto a live site and actually do a bit of work there with the client's permission to actually see what happens, to test it in the real world, to give it some real work to do. So we set up this little site. This is, you can go there. It's the addresses in the slides, which I'll publish later. So this is a very basic site. It's a Praxis theme. It's latest CMS4. Couple of pages, as you can say. There's a few pages on there, bit of text. We didn't want to do anything too clever because it would have taken a lot of time. We've got a couple of galleries on there as well because, again, we wanted to just give it a bit of a test with some real assets. And there's a couple of different things on there. So you can kind of look at that later on. The address is on there, as I say, and you'll see what's what. So basic performance tests. Now, this is all done on a domestic broadband connection, a good domestic broadband connection. So they were all done from the same connection. And what we found was that the initial response time, so the first time we'd go to the site, we would get a time to first byte of 100 to 200 milliseconds. Well, that's pretty good. We were pleased with that. If that was all it had achieved, we'd be pleased with that, because that should be the case everywhere in the world. So we've gone from a system that may take 5-6 seconds to load from Japan to a system that, in theory, should be initially loading in less than half a second. That would be a huge win, absolutely huge win. What was interesting is that the repeat request was much, much smaller. So this one here, you can see, is a 50 millisecond request to load the document. And the total load time, 438 milliseconds, I think it is. This is with browser caching disabled, so we are loading all the assets in every single time, and we get very, very quick load times. And if you look at the waterfall, which you may or may not be able to see, we've got all of these assets are actually coming in via the CDN. The original page is being loaded in from our worker. So none of this touched our origin server, not once. And obviously, we were pretty pleased with that. Lightweight pages without a lot of content on, they load even faster. We've got full load times on there down in the sub 100 millisecond range if you've got a good network connection and good accessibility. And what you'll find is that as the edge networks pick up the data and they start to cache it, so AWS CloudFront, that caches data for popular pages. KV workers also cache data. So whilst your worker is always there in the system, there are caches internally on the data. So whilst the standard response time may be, 10 milliseconds, whatever it is, if it's cached, it's right there straight away, and that comes down to virtually nothing. This is an image-heavy page, so this is one of the gallery pages, obviously a lot more content on there. And again, 41 millisecond response time for the page itself. That's us saying, here's the HTML, do something with it. That means that obviously the user is getting a response. The browser can start to do its stuff much, much more quickly. And again, if you look at the assets are loading in very, very quickly indeed. These are coming via the Cloudflare network. The fact that they're in Cloudflare and Workers is also in Cloudflare is good because we've already got connections set up. And you'll see this is all HTTP2. So there's not lots of requests. There's not lots of transit going on. There's not lots of network conversation that needs to be done. We've already got these connections made. And again, even on that big page with a whole bunch of galleries, the finish time is 727 milliseconds. And that's pretty quick. We were pleased with that. And obviously, again, the origin server, not touched by this at all. Page speed score, just for the sake of it, we looked at it. Obviously, there's not a lot of content on the page, so it's not doing a lot of hard rendering or anything. But the important bits here are how quickly the browser is able to get started on building the page. That's a big deal for Google's page speed. If you ever try to battle page speed, you'll know getting the browser to render the page, to start rendering the page quickly, is a big deal. And this is with no optimization. Don't get me wrong, there's no optimization. It loads in 4 or 5 different style sheets. It's loading jQuery from somewhere, the full jQuery library. There is no optimization in this at all from a front-end perspective. So for a simple site like that, straight out of the box, 95, and on desktop, 98, again, just because it can start to render quickly. And we'd be hoping to get these numbers even better for a site where we spent some time engineering it and making it better from the origin. These are not solutions to badly coded websites. Do it right in the first place, this will help, but this won't fix something where you've got 15 style sheets loading in and a dozen full frameworks, anything like that. That's not what this is about. So that's where we are. That's what we've done. The question really for us is what next? We've got currently plans we're looking at. Once we spin this out and actually do some real-world testing with real-world clients across the world, we'll look at moving some of the more dynamic elements into their own specific worker tasks on their own specific URLs. So things like form submissions. We can do that at the edge. We don't need to send that back to the origin server. Things like social feeds and so forth. We're working currently on an Instagram getter. So rather than, again, going back to the origin server and the origin server querying Instagram and getting a feed and sending it back, we're going to put that all in the edge because it can do it. It's JavaScript. It's a relatively simple job. And again, it's just one more task for every page load we don't have to worry about. And this is focused, as I say, specifically on sites that exist. We are not re-engineering sites. These aren't new builds. These are ways to make existing sites better and to give us as a company a bit more of a value proposition to the clients to actually say, well, you know what, we can do it and we can make it faster and we can make it better for your customers. And we've got another customer that we're looking at this who deal with, they're a charity, they deal with eye care solutions around the world. So a lot of their clients are actually accessing via 3G mobile phones. They've got sketchy dial-up connections around the world, lots of remote areas. And again, this is a way that we've looked at. We already deliver sort of minimal sites to those clients, but if we can move that site out to the edge, closer to them geographically, physically, the hope is that we'll be able to actually make the whole thing faster. And where these cases don't fit, what we've learned, the important thing that we've actually learned in the process of doing this is that you don't need to go all out. There are ways and means you can do this. You can pick and choose the functions that you actually want to do. I've included a few references there. Again, I'll share the slides afterwards. And our test site is there. Feel free to play with it. If you spot anything, you can get hold of me. We've got a GitHub page, and you probably, again, have spoken to us on the forum. Documentation for Cloudflare workers and Edge as well is there, just for the sake of completeness. And that's pretty much where we are. We're going to keep up to date on it. We'll be releasing some information once we get the first test done. We'll probably send that out on the forum and on our GitHub page for the Edge publisher content. Yeah, fingers crossed. It's a way that we can get into using the serverless technology without becoming serverless edge engineers ourselves. If anyone's got any questions, I'll be happy to answer them if I can. You can drop me an email. I'm always around on Slack again, but if there's anything now, feel free to ask away. It's always a worry when Johannes has a question.
No, it's totally fine. Like I said yesterday, we were using a static publisher queue before we switched to a Cloudflare CDN solution. One thing we didn't like with static publisher queue is that if you had some stale content and you didn't want to deliver the stale content and you removed it from the cache, and the user would hit up your site, you would render the response for the user and deliver it to him, but you would not put it in your static publishing cache, and static publisher would have to render it again. So with your solution, do you, if you request content from the origin that should have been cached, do you inject it into your KV store?
We did think about that, and currently we don't, because what we wanted to do was have the ability to bypass the edge kind of without having to deliberately bypass it. So it was more an exclusion. So if we don't push it to there, we're going to assume that we want to deal with it elsewhere. Now, I did think about your comment yesterday where you were having problems with static publish queue just getting too full. And that is a problem, because I've seen that even on static publish sites, which aren't having hundreds of updates a day. And one thing I did think that actually would be quite simple to do is using KV store. There's nothing to stop you when you save, let's say, a data object or a page, actually just pushing that content, just the content, immediately to the KV store.
Sync it there,
and then using a worker to take a template, stuff the content into it. And because you can do this on a per URL basis, you can, if you've got a product catalog or you've got a particular section of the site where there's a lot of changes going on, there's a lot of commonality in template. Again, Stefan touched on this yesterday with his speech, is that you can just take elements and you can stick them together at the edge. So that's something we were actually slightly concerned about as well, was this static publish queue problem that you saw. So
the reason we're not using the workers on Cloudflare is cost.
Right.
Because what we do is we pay $200 a month to Cloudflare for the business plan.
Yeah.
And it's a flat rate.
Yeah.
So we just use the regular cache because that way we can calculate our cost no matter how many users there are.
Sure.
And we were just scared of the requests. It wouldn't be so bad, I guess. The other thing I want to do is I want to advertise Railgun server from Cloudflare.
Okay. Yeah.
If you have any content, like especially this setup where you say you have an old site that is not built for being cached with Cloudflare or front workers, if you have content on your website that cannot be cached for whatever reason, Railgun is a protocol that Cloudflare uses. It sets up a memcache at your origin and one at Cloudflare, and it will only transfer the delta if you request pages again. So if the only thing that changes is the username or like a pricing information, you still have all the work at your origin to render it, but you only send like 1-2% of your pages HTML.
Yeah, absolutely. And the other thing, actually, Cloudflare have just started on workers. I don't know if you've seen this. They've just started doing Cloudflare sites, which kind of duplicates some of the work that we've been looking at doing. I haven't really had a chance. It was only last week or the week before, where they're actually doing a system where you can push directly, effectively a static site to the workers system. As I say, I don't know anything beyond the fact that it exists, so that's something we'll be looking at shortly.
First, thanks for the nice talk. Maybe Johannes also already answered my question a bit. I was wondering, I'm not very familiar with Cloudflare, but I remember that they have a caching already built in.
Yeah.
Why didn't you use it here?
It's a difference in approach, really. With Cloudflare caching, yes, you can just put your site behind Cloudflare, and it's a CDN. You get a CDN. You can do it for free, and you get assets and content cached. The difficulty is you've got very little control over what gets cached, how long for. You can set a TTL for everything, but to do it on a specific basis, you can't do. And what it doesn't do, unless you pay a lot of money, is whole page caching. You only get a certain amount of full page cache within certain plans on Cloudflare. So our approach really was, we do use that system for the assets. So we do take advantage of the caching front end for things where it doesn't matter that we haven't got that level of control. But this way, our thinking was that actually we get to decide what version of a page is out there, whether it's being cached. We haven't got to worry about if we delete a page in the site, Static Publisher deletes it on the edge. And so that request then will just be routed to a 404. So there was a few reasons, and it's obviously a slightly more complex solution. As I say, it's not necessarily a particularly beautiful solution, but it gave us the level of control that we felt was important, rather than just relying on someone else's cache system to make the decisions.
Okay.
Sorry. What plan are you using on Cloudflare?
On this, currently, it's this particular site is actually a free plan with the $5 a month workers. So literally, $5 a month is the cost of what we're doing here. Now, on the client site, there's just a pro plan. Again, $20 a month. It's not one of the big plans. And so it'll go from $20 a month to $25 a month. And that will cover the traffic they've got. That's the key. You've got to do the sums, as you say. So, but 10 million read requests will cover what they want to do. The critical thing for this particular client was to make it quick in all the locations. No one else?
Yep. Lars.
Oh, just a second.
Thank you for your talk and your clever solution. I was wondering, can you maybe elaborate a bit on your on the deployment process you have for updating the workers?
Yeah.
Let's say you start to do more work in the workers themselves on the edge.
Yeah.
How do you deploy something like that?
Well, in this particular case, as I say, we're actually using all the work that SilverStripe did, and one of the people who did it sitting in the room here. So the static publisher process obviously creates, by default, it creates a file on the disk, and that file is delivered. All we do is we put our engine in place of the file publisher, which just pushes the content out. So as new pages, as new content is created, static publisher does the work for that. Now,
but the worker itself is not part of the SilverStripe project.
No, sorry.
How do you
Okay,
deploy
yeah, sorry.
The
worker code itself. Yeah, I'm sorry about. Okay, there's two ways to do it. The way that Cloudflare recommend is they have a command line tool called Wrangler, and you effectively use that to deal with code builds and code deployment. So you give that your API keys, the zone of your domain, and the route that you want that worker to work upon. You can just code your actual code in PHP Storm or VS Code, whatever it is you're using, and then you use Wrangler to do a Wrangler build, which actually compiles the whole thing, and then you just do a Wrangler deploy, and that will push it up to your account on the specific URL pattern that you've requested. So that does sit outside SilverStripe, and I don't think there's a nice way to bring it in. And actually, I don't think there's probably a reason to bring it in, because there's still a separation between that deployment of specific functions. You know, kind of once you've done it, you've done it. It's not something that I think needs probably to be within the SilverStripe ecosystem.
Right.
Okay, any more questions about Serverless? Yeah.
Here we go.
No, I just wanted to add one of the benefits of using the workers KV instead of just relying on Cloudflare's cache is on the cheaper Cloudflare plans, the caching is only per node.
Yes.
And I've got 190 odd nodes, so you know, as soon as somebody hits it from a country that doesn't regularly hit your site, it's going to have to go back to the origin, fetch the page, and so you know, if you've got a one-day cache, you can end up with 195 full origin requests per day, and with the workers KV, when you push it into the KV, it is pushing it out to.
Sure. Yeah,
the various
absolutely. Yeah,
nodes.
that's a very good point. It is, as I say, they call it eventually consistent. So once you push something out to their network, it goes everywhere. So you're not relying on a specific route through a specific data center to serve that content. Dan.
Did you have any issues with editors using the CMS when it's behind all of the CDN logic, or is it quite easy to pass everything through?
We haven't seen any problems. That's one of the things we're actually not concerned about, but it's one of the things we're going to look very carefully at during this first test stage. On our test site, we didn't see any problems with it. It just worked. The one thing that we haven't got that we do need to think about is the preview pane, because obviously the preview pane is never going to see the draft content in its current format. So the preview pane is obviously making the request to the real domain of the site, which is being routed through the worker. So we're going to have to look at a solution to actually make the preview pane either load via a different URL, or there's going to be a way to do it.
When we've done things like this before, we've basically put the entire CMS on like a cms.whatever.com domain. Your draft preview content then goes there, and it's just a direct access to the server.
Right, yeah.
There are some, I can't remember which, there are some variables where you can say when it's publishing it, don't use cms.whatever.com, use a different domain for all the links inside.
Yeah.
But that might help you.
Yeah, and absolutely, that will, because for the most part, I mean, you just stick your origin server with a couple of host names on it, tell the editors to use the admin dot whatever, and then the leftover requests can still be routed directly to that server. So yeah, I guess that's probably the simplest solution, which we like.
Anyone else? Yep.
Just a comment. A brilliant solution. I've been looking at the workers of Cloudflare for a while, and didn't really had an idea how to use them. But this is a brilliant solution for that. So.
Great. Well, please do some testing and fix all the bugs that we've got, because there's loads.
Yeah.
So yeah, commit to it and PR your heart out. Yeah. As I say, I saw it come up last week, and I thought, has this just completely rendered my entire exercise completely pointless? But
You probably use your module to populate workers' sites.
yeah.
Okay, so thank you very much, Tim, for this clarification of serverless.